So we're going to look at this problem. We're going to balance by assigning oxidation numbers. We practiced that yesterday, so I'm going to get you children to assign your oxidation numbers, and then we'll come back.
Oxidation numbers for just like nitrogen and phosphorus? Well, phosphorus
I would concentrate on those two, because remember, we don't have water or oxygen gas or hydrogen gas, so you can assume your hydrogen and oxygen probably aren't changing their oxidation state.
Okay, and
So I'll
phosphorus is 0 just by itself.
Yeah, so I'll pause the video, you can assign your oxidation numbers, and then we'll come back. Okay.
And we're back from our computer.
We've got our oxidation numbers. So, Jessica, what did you get for your oxidation number on your nitrogen here? 5. Plus 5. Plus 5.
Yes.
Alex, what did you get for the phosphorus?
0.
0.
That's
Alex,
That's
good.
boy.
McCain,
Phosphorus,
phosphorus on the phosphoric acid.
7 plus.
I think you're
That's
wrong.
what I got.
Oh, shit.
So we've got 4 oxygens, so that would be a total
Oh,
of
it's my boy, gosh.
-8. Okay, McCain, what is hydrogen's charge in the compound?
It should be. I read that wrong, that's why. Sorry about that. It's +1.
Plus 1, and there's 3 of them,
Yeah, I thought it was,
for a
yeah.
total of
How did you get plus?
+3.
Oh, I was just laughing there.
McCain, we need to add up to 0,
I
so
think we have to add
phosphorus
up
in
to
this
5.
case would be +5.
Sorry about that, YouTube down, so we're pretty done.
Awesome. Let's go back to Jessica for the nitrogen.
I'm hoping it's +4.
+4, that's what I got as well.
Thank ya.
Okay, so that's what we worked on yesterday. Some of us may be a little more diligently than others.
What?
This time,
While you were all judging me.
Miss Russell said pointedly.
so let's look at what's changing.
Yeah,
Essentially.
So our nitrogen has gone from +5 to +4. So we have done what?
Reduced it.
Yeah, so we have gained 1 electron for each N atom. So far, so good?
Yes.
There's only 1 N atom in here, so 1 electron was gained for each nitrate. The tricky part. Okay, so our phosphorus here has gone from 0 for each phosphorus atom to +5. So how many electrons lost for each phosphorus atom?
5.
5.
Oh, wait.
So
What
5
is there?
electrons for each phosphorus atom, but there's 4 P's here. So a total of 20 electrons
Oh, okay.
lost for the P4 molecule.
Well, that's a lot, isn't it?
I don't like this part.
What is next?
So
To do it 18 times.
this is what we're using to balance electrons lost and electrons gained. So here we have lost 20 electrons, but we've only gained 1 electron here. So what do we have to do to balance that?
20.
We're going to multiply this one.
Why do you have to be times it? What many times do you have to 5 and 4?
520. Why are we multiplying the 5 times 4? Because there's 4 phosphorus atoms.
Oh, I
each
thought
of
we were talking about the ones on the other side of the arrow.
Each of those 4 phosphorus atoms have lost 5 electrons. So what's the total electrons lost since there are 4 phosphorus
Oh
atoms?
shit, yeah.
20. Does that part make sense?
Yep.
Okay. So now that we've balanced our electrons gained and our electrons lost so that they're the same, we can balance our non-HNO atoms. So have we messed up our N's?
Yes.
We've seriously messed up our N's. We've got 20 here and only one here. So how do we balance them? Times by 20.
This is the messiest process I've ever seen.
We've got 4 P's here, and only 1 P here. Times by 4.
And we're all done.
Now we're done our non-H and O atoms. Next we can do our oxygens. So let's do some counting.
Let's see, 60
We've
oxygens.
got 60 oxygens here.
And then,
We've got 16 plus
and then 56.
and 56 here.
Oh, we even have 4 waters.
So which side is sufficient oxygen?
Right.
All right. So how are we going to fix that?
Plus waters.
We're going to add 4 H2O liquid.
Then you gotta balance the line.
Now we've got to balance the hydrogens. We've messed them up. So on the left, it's easy accounting. There are no hydrogens. But on the right, we've got
There's
4 times 3 is
16.
12. So 16 hydrogens,
Wait, 12, oh wait, no,
12,
it's H2, sorry.
20. So we're going to add 20 protons to the left. Last thing, we're acidic. So are we done?
Wait, we're adding OH, should we just add
this is
H?
basic.
Oh, sorry. No, I wrote 20 to the
Oh, okay.
Oh, that's
Oh
gross.
boy, oh.
That's a 20.
Oh, your O's look like zeros.
How can I make them more zero looking?
I don't know, make them
A
slimmer.
line.
Make them slimmer or?
I don't know, if you look on your thing, it's
I
like,
guess-
oh, they're slimmer than, I mean, like the zeros are slimmer than O's.
No, it's not.
Yeah, they are. Shut up.
Alright, no, O's are shorter than zeros.
At any rate, are we balanced?
Yes,
Yeah, this is the thing. So we're done.
that's all we have to do.
That's all we have to do.
Fun time.
So you've got 2 methods. You've got your balancing by oxidation numbers method. Not my favorite, but you may like it. There's less writing. And then you've got your balancing by building those redox half reactions. Oh, but you guys wanted to do another together of balancing by making half reactions? Yeah. Do we still want to do
No,
that?
let's do the exact same equation.
Yes. Do you want to?
Why not?
I mean, I said it in a way that
Yeah,
it's like,
the
it's fun to
audience
ask,
at
but
home.
sure, why not? Let's do the same one.
Okay, you can do the same one.
Yeah,
Because we should get the same answer, just,
No.
just by a different method, right?
What counts as the answer? Just the end equation that we got?
The end balanced equation, yeah.
Okay. Well, if we did it one way, we'll just copy.
So we're using a different method now.
Oh.
This one's kind of nice in some ways because we don't need to figure out really what's being oxidized or what's being reduced at the beginning. We're going to pick out the things that look the same. So these things kind of look the same. So with building that redox half reaction, we're going to take our nitrate and it's going to make nitrogen dioxide gas. Next step, we'll balance all of our non-hydrogen oxygen atoms.
That's good.
They're good. Our ends are good.
Cool. Add water.
Now we need to balance our O's by adding water. So we've got 3 O's on the left, 2 O's on the right.
just add one.
Just one water. Okay, now we've messed up our H's.
You got them 2 hydrogens.
So we have to put 2 protons here.
Then we're done with half.
Then we need to balance charges by adding electrons. So our total charge on the left side of the equation, we've got 2 positives, -1, so +1, and 0 charges here.
Plus one on the right side.
Perfect. So we're going to
Wait, no,
add
plus one on the left.
1 electron here.
I like this one more.
Perfect. I do too. This way is my preferred method. Okay, so we've built a half reaction.
Oh, great.
So we get to do the same thing, or with our P-type, our phosphorus-type compound. So we've got P4 goes to phosphoric acid.
You gotta balance it.
We've got to balance the P's.
There's 4 P's, so you have to put a 4 on this side.
We're going to put a 4 here. Then we get to balance our O's with water.
4, I
I
know.
love doing more shit.
So 4 times 4, we've got 16
16.
O's. So we're going to add
16
waters here.
Now we gotta balance the hydrogen.
Now we've got to balance our hydrogens. We've got 32 on the left
30.
Oh,
Wow.
shit.
Yeah.
and 12 on the right.
Oh. Well, you said we're 32.
10.
I'm stupid. Sorry. 20.
Yeah. Yeah, but then my calculator, I'm like, well, Alex is so smart. He's got a calculator.
20 protons.
It's pretty much pretty.
Next, we're balancing our charges with electrons. So what's the charge on the left side of the equation?
32.
On the
That's
left.
water. It's 0.
0 and 0. So 0. Right, let me just highlight for those that didn't see me pointing. 0 and 0. And no charge and 20 pluses.
So 20 electrons on the right.
We're doing 20 electrons here. Before we can add these up, we need to make sure that the electrons that we lost equal the electrons that we gained.
Yeah, I kind of put this one.
We have to times our entire top by 20.
Then we write a net, don't we?
Then we write a net.
Well, part of our water is going to get
Part of our waters can get canceled out. So one thing that I would suggest, if this was for a high stakes diploma, I would distribute my 20 in and rewrite it, and then do my canceling, so that I make sure I'm not messing anything up.
That's fine.
We don't have a lot of room here for this, but I'm gonna write into this next problem and do that, just to make sure I'm not missing anybody. Alright, so I've got 20 electrons then, plus 40 protons, plus 20 nitrates, makes 20 NO2 gases, plus 20 waters. And underneath that, I'm going to stack, oh, I got 2 stack. Sorry, did I rewrite the bottom one?
No.
Okay. So we can add this up. Just to see we get some water
She
cancellation.
only got 4 waters in the
16 gone here, with 4 here. Any
Hydrogen, you have
protons?
20.
We've got
You have 20 left.
20 left. Where are we? There's 20 here gone. And 20 left here. Anybody else got canceled?
Electrons.
The electrons. Now we get to write whatever's left over.
We just like rewrite it.
We just rewrite what's left over. So P4 plus 20 protons plus 20 nitrates. Did I get everyone on the left? Makes 4 phosphoric acid. And 20 NO2 plus 4 waters. We got what we got last time.
Was it?
It's so long ago, I don't even remember.
Yeah, you were.
Yeah. That's what we got
that's-
the last
That's
time.
great. Cool. Let's do 3.